Okay, so we got two problems here. The first one, find the exact riser height in the stair opening when we have a floor thickness of 25 inches and a ceiling height of 7'9". So we need to find our total rise. How do we find our total rise? Perfect. So 7 feet into inches, 7 times 12 is 84, plus 9 is 93, plus the 25 floor thickness is 118 inches total rise. Then what do we do? Divide that by 7, which is going to give us 16.857143 approximately. So what does that mean? Now, here's a case where we're going to have to round. This is one of those always spots, gentlemen. This is always round down, no matter how close it is to the next one up, because we don't want to go smaller than 7 inches if we can avoid it. We can go bigger, but we'd rather not go smaller. So we're going to round this down to 16 rises. Then what do we do? Divide 118 by 16, giving us 7 3/8 inches. That is our exact riser height. Now what? To find the stair opening, we have to start with finding what? The required drop. The required drop is always floor thickness plus what? 6 foot, 6'4" head clearance, 76 inches. So it's 101 inches. What do we do with that? Divide that by 7 3/8 to figure out how many risers that's going to be. So 101 divided by the 7 3/8 is 13.69. Here's another always round issue. This one, however, always rounds up. That's 14 rises. How many runs is that going to be? 13 runs. Always one less than the number of rises. Now, I did not give you, nobody asked, 11-inch tread or 11-inch unit run. If you're not given the tread, always assume 11 inches. If we're using an 11-inch tread, 13 runs, 13 treads times 11 inches is going to give us 143 inches, which is what? 11 feet, 11 inches. If you had it listed either way as 143 or 11 foot 11, either one would be acceptable. Does that process look familiar to everybody? How many are confident you can do that on your own? Like on a quiz in about 8 minutes? Any questions on that? Okay, so that's just our process from last Tuesday. Now we're taking a little bit of a step further back here with our hip roof. We want to find the jack rafter decrease on each side of this roof. We always start out with the common. What do we know about the common? What's the slope? That's the 512. What's the span? Well, 30-foot span, but you're right, 15-foot run. So where do we go from there? You got 5 of 12 equals h over 15, so we do cross multiply and divide. 5 times 15 is 75, divided by 12. is a height of 6 1/4, right? 6 1/4 feet. 6.25 feet will do for simplicity. So then what? Yeah, we find our common rafter length by doing the square root of 6.25 squared plus 15 squared. Which gives us 16.25 squared. Or 16.25 feet, I should say. So that is right here. This is 16.25 feet. What's next? We can work with the jack rafter. Actually, what we need to find is the longest jack rafter, and we'll use that to help find our setback. So there's two things we need to find. We need to find the setback here, and we need to find this longest jack here. And both of them are going to come off the same diagram right here. And there's two things we know about this. What is the slope? It's the 11, 12. What else do we know? The height is still 6.25 feet. It has to have the same height as the common does. So from that, we know that 11 over 12 equals 6.25 over that setback. So we cross multiply and divide. 11 times 6.25 is 70, or sorry, 12 times 6.25 is 75. Divided by 11 is 6.55, or I did 10.11. 6.81 is what it comes out to be, feet. So we're at 6.81 feet is our setback. Now we can find that length. How do we find that length? You got it. The square root of 6.81 squared plus 6.25 squared. So second square root 6.81 squared plus 6.25 squared. We get 9.249. So this right here is 9.249 feet. Now we could find, we didn't ask for it, but we could find the hip rafter. The hip rafter could be found from either side. I'm going to double check it in both directions. From the hip side, I've got the 15 feet squared plus the 9.249 squared. From the main roof side, I have the 16.25 squared plus the 6.81 squared. Let's see if it comes out to be the same answer either way. So the square root of 15 squared plus 9.249 squared. 17.6222. Or the square root of 16.25 squared plus 6.8, technically round to 82 squared. 17.623. So it comes out to be pretty much the same. 17.623 feet is the hip. Now, I didn't ask for that here. I asked for the decrease on each side. So let's look for the decrease on the main roof side. What are we going to use for triangles there? Got 16.25 here, right? And the 6.81 here. And this is 4.81, and we'll call this y. Yep. So then the proportion 6.81 to 4.81 equals 16.25 to y. So you had it right. So you cross multiply and divide. 4.81 times 16.25 divided by 6.81 gives us 11.478. You got it. We subtract that from 16.250, which is going to give us 4.478. .772, I believe. Works for me. So then we have the hip roof side. This is going to be 15. This will be 13. And up here is the 9.249. We'll call this X. So we've got 15 over 13 equals 9.249 over X. Cross multiply and divide there. So 9.249 times 13 divided by 15 gives us 8.016. 1.233, close enough, feet. So we've got the two decreases. Any questions? How many are ready for a quiz on those?
That was completely on purpose.
Settle this. So looking at this one here, let's say I'm going to tell you that the main roof here is a 612 slope. These valleys are actually exactly the same as a hip calculation. So let's take a peek here. We're going to start out with the common. Our common rafter has a span of 30 feet, a 612 slope. We're looking for the height. The run is half of the span of 15 feet. 6 over 12 equals h over 15. This is an example, so it's not one that's actually on the quiz. So we've got 6 times 15 divided by 12 gives us h is 7.5 feet. So now we can find that common rafter length, which is going to be this length right here, which would be this length right here, is the square root of 15 squared plus 7.5 squared. Giving us 16.771 feet. So this here is 16.771 feet. Now then we're going to use that on the, this is actually referred to as an L here, the L roof side, to find this. That we know has a height of what? .5 feet. We know that the span here is just half of the 18-foot span. It's 9 feet. So we can find that length. This be the square root of 9 squared plus 7.5 squared. Giving us 11.715. So now that we have all of these main rafter links, to find the next one here, I'm going to have a couple of triangles. This is on the main roof side. My first triangle is 16.771 feet. What's this distance up here? That'd be this distance, which is half of the 18, 9 feet, right? So my next triangle, the one in the red, that would be 7 feet, and this we'll call y. So we have 9 over 7 equals 16.771 over y. Cross multiply and divide. So 16.771 times 7 divided by 9 gives us 13.044. We subtract to get 3.727. That would be the decrease on the main roof side. On the L side, I'm going to start out with this triangle. This is the 11.715. Here, what's this distance? 15 feet, right? Then I'm going to shrink down to the next one right here, where that distance would shrink to 13 feet. We'll call that X. So we now have 15 over 13 equals 11.715 over X. Cross multiply and divide. 11.715 times 13 divided by 15. 10.153. Which is going to give us 1.562 feet on the L side. So it's the exact same calculations. Either of you guys want your quiz back? Yeah? Okay. On to those quizzes and turn them in on Thursday. We're going to cover some new material, so we got the material that you guys are going to have to do on Thursday for quiz. What's that? No class, no math on Wednesday. You guys won't see me till Thursday. Because there's never a Wednesday math class. Yes. This Friday? Our new topic for today is variation. So like I said, you can hold on to the quizzes and bring them in on Thursday. Variation describes how two quantities interact with each other. We're going to start out with direct variation, which we've explored in a lot of ways already. Similar triangles is a form of direct variation. And direct variation, if one value gets bigger, the other value also has to get bigger. Or inversely, if one value gets smaller, the other value also gets smaller. There's a couple of different relationships for direct variation. Direct variation is a constant ratio. So x over y or y over x equals a constant. Usually we do express it as y over x equals a constant. Another way of expressing it, though, an alternative way, is that y is equal to a constant times x. Now, one of the examples we showed you of this is similar figures. If I have a triangle that we enlarge, let's say this was 6. I want to mark these angles. Let's say this was 6, 9, and 12 feet here. And let's say this is going to be 8 feet. Finding those other values, well, 6 became 8. It got larger. 6 over 8, that's my y over x. It's a constant ratio. So my ratio of 9 to x is going to have that same ratio. We set up a proportion. Direct variation is what we refer to as proportional. We cross multiply and divide. 8 times 9 divided by 6 gives me 12 feet. We could do the same type of thing to find y. Probably would have been less confusing if I had used like a and b for these sides instead of x and y. But you guys get the picture. It's a constant ratio. So if I give you the statement y varies directly with x. What that means is it one of these two forms, y over x equals k or y equals k times x. Usually I'm going to use the second one, y equals a constant times x. Now generally we have a little bit more information that we might have y varies directly with x and y is 27 when x is 9. Now there's two pieces of information here. The first one is right here. Y varies directly with x. That's just telling us just what we had up here. It's that relationship, y equals k times x. Our second piece of information allows us to better define that relationship. Y is 27 when x is 9. So we put 27 in for y, 9 in for x, and we can figure out what k is. We divide by 9 here, we get 3 equals k. So what that's telling us is that this relationship, to be more exact, is not just y equals kx, but y equals 3 times x. Any questions so far? We can take it a step further, and we can say y varies directly as x. Y is 36 when x is 9. Find y when x is 7. So now there's even more information. There's two pieces of information still. Y varies directly with x still means that y equals a constant times x. Y is 36 when x is 9. This is what we call an initial condition. It's a condition that we know the values of both variables. We took a measurement and we know those values. So y is 36 when x is 9. We put those values in. And we can solve to find k. Dividing by 9 tells us that k equals 4. So now we can further define this relationship as y equals to 4 times x. And now then we're asked to make a prediction or to make a calculation. Find y when x is 7. Well, if this relationship is true, when x is 7, y equals 4 times 7, or 28. This gets used a lot in engineering where you maybe don't know the formula for something, but you know the type of relationship. You know that it's a direct relationship. Or coming up, we'll know it's an inverse relationship. And you know that one set of conditions is true like this. We know that when it's 36, the other one is 9. And then we can use that relationship along with what we know from that initial condition to try to figure out a value if we change things around. Now, it's not always quite that straightforward. We can have something like y varies directly with the square root of x. Y is 18 when x is 9. Find y when x is 25. So the difference here, y still varies directly, so y equals a constant times, but it's not going to be k times x. It's going to be square root of x, k times the square root of x. So that's our relationship. We still have that initial condition. Y is 18 when x is 9, so we put them in. Y equals 18 equals k times the square root of 9. Now there's just an extra step here that we have to solve. What's the square root of 9? 3. Of course, it could also be -3, but we're going to just go with the positive for now. And now we can solve for k by dividing by 3. 6 equals k. So that tells us the relationship is really there we go. Y equals 3 times the square root of x, right? Oops, 3, where did 3 come from? How about 6 times the square root of x, right? Now it could be the positive or negative 6, but we're sticking with the positives for now. Usually the situation will tell you whether it makes sense for that to be positive or negative. So anyway, what would be our next step? Perfect. Find y when x is 25. So we put 25 in for x. So y equals 6 times the square root of 25. So the square root of 25 is 5 or negative 5. We're going to go with just 5. So 6 times 5 is 30. Y would be 30. Make sense? Doesn't always have to be y and x. It could be any variable. P varies directly with m and d. Doesn't always have to be just 2 variables. Sometimes it can be more. P is 80 when m is 8 and d is 2. Find P when m is 5 and d is 6. So here, our first piece of information. P varies directly with m and d. P equals a constant times m and d. This is called joint or sometimes combined variation. We have more than 2 variables. We still have an initial condition. P is 80 when m is 8 and d is 2. Now we do have an intermediate step. We're going to do 8 times 2 is 16. And now we can solve for k by dividing by 16. So 5 equals k. So that tells us the relationship is P equals 5 times m times d, 5md. And then you got it. Find it when m is 5 and d is 6. So it's 5 times 5 times 6. 5 times 5 is 25. Times 6 is 150. So P would be 150. What do you think? Good stuff? We have inverse relationships. Inverse variation. We saw the direct variation is all our similar figures. The direct variation is everywhere. Inverse variation is also everywhere. We just often don't realize it. In inverse variation, if one value gets larger, the other value has to get smaller. Or likewise, if one value gets smaller, the other one has to get larger. So the relationship here, this is not a constant ratio. This is a constant product. So it's a constant product. X times y equals a constant. And the alternative way of writing it is y is equal to that constant divided by x. So if we have y varies inversely as x, that's telling us it's going to be one of those two forms. Y is 6 when x is 4. What's this telling us? Again, y varies inversely as x. We know that y equals, instead of a constant times x, it's a constant divided by x. Then y is 6 when x is 4. So y is 6 equals k over 4. Now to solve for k, we're not dividing, we are multiplying by 4. So 24 equals k. That tells us that the relationship is y equals 24 divided by x. And yes, we can go that next step. Y varies inversely as x. Y is 9 when x is 4. Find y when x is 3. First of all, is y going to be bigger or smaller than 9 here? Bigger, because x got smaller, y has to get larger. So we're given the relationship y varies inversely with x. So y equals k over x. What's next? Yes, y is 9 when x is 4, so we put in 9 for y, 4 for x, and then multiply by the 4. So 36 equals k, which means perfect, y equals 36 over x. And then y equals 36 over 3, which is 12. What do you think? Good so far? Now it can get trickier. Y varies inversely with the cube of x. Y is 15 when x is 2. Find y when x is, oh, what do I want to put in here? Let's go 5. So where do we start? K over x cubed, right? And then perfect. We put 15 in for y, 2 in for x. So 15 equals k over 2 cubed. Now we have to do what? We have to cube the 2. 2 cubed is 8. And then multiply by 8. So 120 equals k, which tells us y equals 120 over x cubed. Perfect. Then we put in 5 for x. So y equals 120 over 5 cubed, which is 120 over 5 cubed is 125, which is 24 over 25 or 0.96. Y varies inversely with M and P. Y is 30 when M is 2 and P is 4. Find y when m is 16 and p is 5. Yep. So y equals k over m times p, or k over mp. Perfect. We put 30 in for y, we put 2 in for m, and 4 in for p. So 30 equals k over 2 times 4. So 30 equals k over 8. Multiply by 8. 240 equals k. And then y equals 240 over mp. And then y equals 240 over 16 times 5. And then y equals 240 over 80, which is 3. Y varies directly with x and inversely with z. Y is 40 when x is 2 and z is 12. Find y when x is 5 and z is 40. So this is combined variation. We have both direct and inverse. Y varies directly with x. So that's the constant times x, because directly means you're multiplying the constant. Perfect. And inversely with z means it's divided by z. Perfect. Perfect. So y is 40, so we put 40 in there. X is 2 and z is 12, so y 40 equals k times 2 divided by 12. Now here, there's a lot of things I could do. I'm just going to do a two-step process. I'm going to multiply by 12. So that's 480 equals k times 2. And then I'm going to divide by the 2. So 240 equals k. I could have combined the 2 and the 12 to get divided by 6, but that's easier just to multiply by the denominator and divide by the numerator. So y equals 240 times x divided by z. Then what? Perfect. Y equals 240 times 5 divided by 40. 240 times 5 is 1,200. 1,200 divided by 40 is 30. Y equals 30. What do you think? Doable? Okay, I gave you guys a worksheet. That worksheet is on variation. I will warn you, on Thursday at the start of class, there will be a quiz on variation. Then Thursday, after that quiz, we're going to work on that truss packet. Make sure you have that truss packet with you. Because on Friday, there'll be a quiz on the truss packet. Good. Next week, Tuesday, will be our Unit 1 test. We're going to be wrapping up Unit 1 here. So next week, Tuesday, the first hour, we'll start the test. And then after that, we will actually, I'll let you take the test home to finish it. After that, we will actually start Unit 2 materials. No, the trust packet you don't have to turn in, but you're going to need it with you on Thursday so that we can go through some of those examples. Trust packet has the measurement stuff on the front. No, it's actually a typed up one. It's not actually copied out of a book. Nope, it doesn't say chapters on it. The front page is all adding and subtracting measurements. Yeah.